Okay, this is a video on how to take a SSA1000 graph, which is a force displacement graph, and convert it into a stress strain curve using MDSolids and Excel. So let me get started here. Okay, so here's the graph that we got out of our stress analyzer. If you click on the show data, it actually gives you the data points, the X and Y coordinates that are used for the graph. We're going to be taking that data and importing it into Excel. So this is just a DAT file, which is just a data file. It's basically a text-based document that we're going to open up in Excel. So that's what I'm going to start with now, is opening Excel. Okay, so now that Excel is open, I'm going to open up that data file using Excel. And so down here I have to click on File Type. I have to pick All Files, and Brass Sample 2012 is my DAT file that I'm going to be using here. So here I want my delimited values because I have commas that are separating, and I want those to be in different columns. So I pick comma, and that then allows me to put it in two different columns. Click on Next, and General is fine. Finish. So now I have my data into this is a displacement column and a force column. And here's where I want to start making some changes. The first thing I want to do is I want to identify some points. So this right here is the origin. That one's pretty easy to identify. And I'm going to ping back and forth between my SSA1000 and this. So I'm going to look at my graph here. And if I look, it kind of goes pretty linearly up until about this point here, and then it starts to deviate from that line. You do have a little bit of a dip here in the slope, but I'm going to call this point right here my proportional limit right here. So this is right around 200 or 760, somewhere in that range, and a displacement of 28 thousandths. So if I look in my Excel spreadsheet, I'm looking for 27 thousandths and 762. So there it is, 28 thousandths, 762. So this right here is my proportional limit. I'm going to highlight that. I'm going to highlight my origin. Those are 2 points I want. And now, because these data points in here don't really matter, because my modulus of elasticity is the straight line between those 2 points, I'm actually going to delete all of these cells in between. Okay? Because I'm trying to reduce the number of points that I'm using, so that way when I plug it into MDSolids I only have about 20 to 25 data points. The next point that's important is the maximum force, or the ultimate point here, and that is at 832 and a displacement of 45 thousandths. So I'm going to go into here, 45 thousandths, 832. And if you notice here, there's multiple 832 points. So I'm going to go right in the middle. I'm going to use this as my ultimate point. And then I'm going to go and find my breaking point. Now the easiest way to use the breaking point is look at your data. And it makes a lot of sense. It goes 670, 660, 650, 640, 630, and then drops to 276. So what has happened here is okay, so at 637, this would be our breaking point. Because again, the force has dropped off significantly, so the machine is just trying to go back to zero in terms of the force, and it's taking a little bit of time to do that, so it catches another data point on the way down. But from this point down, all this data here is garbage, so I'm deleting all of that. And then if I want the graph to drop straight down, so at this point I want it to drop vertically straight down, what would that mark be? Well, my x-coordinate would be the 0.093, and that would be my x-coordinate. My y-coordinate would be 0 pounds. So in my Excel document, I'm going to have this 93 thousandths and 0 pounds. I'm going to call that the end. So those are two more important points that I need to keep. Now what I'm going to do is I'm going to delete a majority of the points in between, just so I keep my basic structure of my graph. So I'm going to hold down Control and highlight all these points here. I'm going to right click and I'm going to delete those so they're gone. I'm going to do the same thing after the ultimate point. And again, if it doesn't work out perfect, just try to delete quite a few, because now if you look, I have roughly 25 data points from here to here, which is what I want. I want to stay in that range. This should give me pretty close to the same shape as my original. Right now I need to change this from thousandths of inches to actual inches. So I'm going to do an insert column, and I'm going to put an equation. It's equal to A4 divided by 1,000. So what that's going to do is take this value divided by 1,000. And if I crosshair this and click and drag, I can copy that formula here. The next thing I'm going to do is go over to the this is my decimal, how many decimals I have, and I want 3 decimals for those. And you can see now that I've got this in thousandths, or this in inches, and this in pounds. Highlight these two, insert, scatter, and you can do a smooth curve is fine. And now you should notice that I get basically a representation of this graph right here. And that looks pretty good. So now I'm ready to take my data and input it into MDSolids. Okay, once I've got my graph set up in Excel, should be ready to go. So open up MDSolids and I'll show you where to go here in just a minute. Okay, here we have MDSolids opened. I'm going to click on Problem Library and Material Properties and Stress Strain Curves underneath that. And I'm going to move this off to the side, and actually I need to close that first. I'm going to try to make it so I can see my Excel data as well. So I'm going to move this over here, open that back up, and now I can see my Excel data and my MDSolids. So here I'm going to start putting in my data. I'm going to make sure that my units are correct with pounds, inches, psi, and inches per inch, and then my area is in inches squared. And a thing to remember is this is force, this is deformation. So force is actually this column, and deformation is the same thing as the displacement, which is this column here. I'm going to reduce this and move it over here. And now we can see between the two and get our data inputted. So I'm going to just take a minute to fill in this stuff, and I'm going to pause the video and then come back when I have all this filled in. Okay, I've got all of my data put in now. So again, make sure that your forces are on this column and your deformations are on this column. That should be in inches. Again, we're using this column here in Excel and this column here for our force and our deformation. I've put in all 26 points. And you can see the last one's the breaking point, and the end point should match up there. I've put in the gauge length. This is how long our sample was, and this is the area from the diameter. So we took the diameter, which was 0.119 inches, divided by 2. We squared it, multiplied times pi to get the cross-sectional area of that. The last two things are the point that is my proportional limit. If I look at my Excel data, that is this second point right here in my data on MDSolids. So my proportional limit is going to be at 2, and I'm going to pick the 0.2% offset method to find the yield point. When I'm done with that, I'm going to hit plot. It then should give me the plot that we had in Excel. Here's my 0.2% offset method, and here's basically a summary of all of those different values for our summary. And this right here is kind of an explanation of what those different points are. So very good to kind of have. And again, I require you to copy and paste this. Copy and paste your summary and take a screenshot of your graph and put all of that into a Word document that you fill out. So hopefully that helps you be able to convert from data in the SSA1000 to Excel, and then converting your Excel data over into a MDSolids stress strain curve. Because now we have stress, which over here is in, these are in thousands of PSI, and your strain is in thousands of inches per inch in terms of our units and our quantities there. Hope that helps.